this afternoon. So I will request again to the participant that please make it a two-way communication. Please ask the questions whenever you feel the difficulty during the session, or I will expect from the participant that they will try to clear their doubts by discussion with our faculty, sir. So I will not take much more time. I directly hand over to Sri Satish Pandey ji to share his presentation as well as his experience with the participant on the subject. Thanking you.
Uh, Thank you, Mr. Gupta, for this brief introduction. And as Mr. Gupta has informed us, like this presentation is basically focused on utilization of iron and steel slag in road construction. So slag is a kind of a very generic term which can invariably use for all sort of waste material which is generating into different type of industry like power, copper, iron, steel, like that. But this particular presentation is on the utilization of iron and steel slag in road construction. So I'm just sharing my presentation with all of you. Is this presentation is visible to you?
Sir, minimum. Yes, sir, visible, sir.
Okay, okay. So let us begin with this. Like in
Yes, sir, visible.
presently, yeah, I think I am audible to all the participants.
Yes,
Am I
sir.
audible to all of you?
Yes, sir. Yes, sir.
Okay. So in India, we have around 18 to 19 million ton steel slag generation annually in India. And if we will couple it with iron slag, then it will be around 40 to 60 million ton. And this particularly this steel slag production is going to increase to 60 to 70 million ton by the end of 2030 with the proposed capacity augmentation in different steel industries across the country as per the national steel policy. So the disposal of steel slag is one of the major concern to iron and steel industry, since the majority of iron slag get utilized into cement manufacturing. Besides that, there are different applications also. But as far as the steel slag is concerned, like it has the difficult problem in disposal of it. So in this direction, the CSIR CRRI has recently converted this steel slag as a road making aggregate. So in my subsequent slide, I will show you the work which we have done in this particular area. Now, as per an estimate, like in India, we require around 1.2 billion ton natural aggregates annually for construction and maintenance of roads. So it's a huge quantity. This sort of demand is meted out by the unsustainable quarrying and mining of rocks, mountains in and around the project site, which is causing significant change in our topographical structure. Besides that, posing serious environmental threat. So due to that, the National Green Tribunal and Honorable Supreme Court of India even banned this quarrying and mining activity in and across number of states, as well as prohibited the use of the locally mined material there. And by virtue of that, the cost of lead of good quality aggregate has been increased significantly. And in some of the states, even it is brought from 400 to 500 kilometer far distance. So this in such type of scenario, it is imperative to use the alternate aggregate or particularly the industrial waste which can be utilized in road construction activity. So this is just a glimpse of the topographical changes like which is caused by the illegal stone mining near Aravali. So now this the extent of desertification even reached up to Delhi and Haryana. So this quarrying and mining activity, particularly in Aravali region, has been completely stopped. And now, despite that, there is still illegal mining is going on, which is one of the major concern to public agencies. So what we can do in this particular area, like we can find out the alternate materials or the marginal materials which can be utilized in road construction work as a substitute of natural aggregate. So In order to give you a brief overview, like in iron and steel industry, normally three types of major slags are generated. So first one is the blast furnace slag, which is generated during the conversion of iron ore into pig iron inside the blast furnace. Therefore, it is termed as a blast furnace slag. Slag is primarily the impurities which is accumulated on the top of a molten iron in the form of a flux, and it is tapped from the furnace in at around 1500 to 1600 degree centigrade temperature. Subsequently, it is subjected on air cooling, and through which we can have the different type of slag based material like air cooled blast furnace slag, expanded blast furnace slag, pelletized blast furnace slag, and granulated blast furnace slag. So among these four types of blast furnace slag, the major two are the air cooled blast furnace slag and the granulated blast furnace slag. So if the blast furnace slag is air cooled, then it can become a source material for as a substitute of natural aggregate in road construction. And if it is granulated with the help of water quenching process, then it get converted in the form of a granulated blast furnace slag, and this type of slag can be directly utilized for the production of Portland slag cement PSC. So as per the advent of new IRC code, like the 30% replacement of OPC has been permitted by using ground granulated blast furnace slag in pavement quality concrete, so PQC. So in case if you want to do cement concrete road work and nearby the ground granulated blast furnace slag is available, then you can directly mix this particular material as a replacement of ordinary Portland cement inside the uh, uh, concrete mix, and you can prepare your M40 grade concrete accordingly. So this is one of the major application of blast furnace slag. Besides that, like the GGBFS, ground granulated blast furnace slag. Yeah, just hold on for a while. Hmm. वो दिया तो है तुम्हें साथ में डॉक्यूमेंट। गगनदीप से बात करो आप। So it can be utilized as a air cooled, like granulated blast furnace slag can be further grounded in the form of a ground granulated blast furnace slag, and it will have the fineness as equivalent to cement, and therefore it can be utilized for the production of Portland slag cement, or it can be directly replaced in the pavement quality concrete as a 30% replacement of OPC for the manufacturing of pavement quality concrete, particularly the M40 grade concrete. So these are the applications of blast furnace slag. Now the hot metal from the blast furnace, sorry. Now the hot metal from the blast furnace goes into the steel furnace, where this hot metal get converted in the form of a mild steel, and based upon the type of furnace which is employed for the production of steel, this slag can be once again classified as a basic oxygen furnace steel slag and electric arc furnace steel slag. Now, in the basic oxygen furnace, like this is a type of a furnace in which the steel production happen. Now, the oxygen is inserted inside the furnace in order to remove the impurities, and the dolomitic lime is utilized as a fluxing agent, which basically remove the impurities and reduce the carbon content into the hot metal and bring it to the less than 4%, 4 to 5% like that. So during this particular process, once again, all these impurities are accumulated on the top of a molten iron in the form of a flux, and it is tapped from the furnace in a molten form at 1500 to 1600 degrees centigrade temperature, and subsequently it is air cooled. So once it is air cooled, it become a basic oxygen furnace steel slag, which is one of the good potential material for utilization as a substitute of natural aggregate in road construction. And in the similar fashion, like there is another version of furnace which is called electric arc furnace. Now the major difference between the basic oxygen furnace and electric arc furnace is the method through which the arc is inserted inside the furnace. So through this three lens, the arc is inserted inside the furnace in electric arc furnace process. And in this particular furnace, along with the hot metal, we can put 40 to 50% steel scrap, which is not possible in the case of a basic oxygen furnace. Like in this particular process, the majority of raw material should be the hot metal, means the freshly prepared pig iron through the basic oxygen blast furnace process. While in electric arc furnace, you can go for the steel scrap, and 40 to 50% steel scrap can be utilized along with the hot metal for the production of steel. So in this type of furnace, the slag, once again the slag is generated in the form of an impurities at the top of a furnace, and then it is tapped, and when it is air cooled, it becomes the electric arc furnace steel slag. So in terms of the mechanical, physical and chemical properties, basic oxygen furnace slag and electric arc furnace steel slag differ considerably. So we have developed the customized treatment process in order to treat these two type of slag as a road making material. The third type of slag, like in terms of the quantity which is very less, is the ladle slag. So this is called the secondary slag, which is generated during the secondary processing of steel. Like in case if you want to manufacture high grade steel or alloy steel, then we need to do the secondary processing of steel, and it is carried out in the ladle slag. So the ladle slag is comparatively acidic in nature, and due to its high toxicity, it is not recommended to be utilized as a road construction aggregate purposes. Once this ladle slag, the steel can be utilized in the form of a billets, blooms, and slabs, and it can further goes for the rolling and main products like that. So this the during this particular process, the amount of slag which is generated inside the furnace is around 150 to 200 kg for per ton of steel production. So around 15 to 20% slag generation is there in case 1 ton steel is required to be produced inside the furnace. So this type of slag is huge in volume and poses significantly disposal issues to the different steel industries, and therefore we developed its utilization as a road construction aggregate. And I will in subsequently slide I will show you the way like how it can be done. Now here is the glimpse of the entire process which is carried out inside the steel plant. So in the first photo you can see the molten slag is coming out from the furnace. It is tapped from the bottom. Later on it is transported to the slag pit, so where the air cooling is carried out. Once it is air cooled, then the magnetic separation and crushing may be required to be carried out as per the type of the slag generated in the slag pit, and subsequently it can get converted in the form of a coarse aggregate. Now the another method to process the slag is its granulation. So in this particular process, this molten slag is directly poured into the granulator, where under the through the water quenching process, the slag can be converted into the sand size particle, and it is called as a granulated slag. And normally this type of process is employed in blast furnace slag, like the slag which is generated inside the blast furnace during the production of pig iron through the iron ore. And this blast furnace slag can be utilized in the form of a fine aggregate, as well as if it is further grounded, then it can be utilized as a ground granulated blast furnace slag, which is due to high hydraulic activity, can be utilized as a direct replacement of cement in pavement quality concrete. So here the sand size particle is basically of granulated blast furnace slag. And in this particular process, like we have to use a VSI, vertical shaft impactor, in order to make the slag particle spherical in nature. And subsequently this fine aggregate can be a good replacement of natural sand also. So the JSW steel plant at Bellary has established this slag sand plant there, and they are converting this a blast furnace slag in the form of a slag sand particle. So in comparison to the steel slag, the blast furnace slag has low density, and therefore a conversion of this sort of material in the form of a sand sized particle is pretty easy in comparison to the steel slag. Besides that, the steel slag contain high amount of manganese and the different sort of high metals, so which may cause the environmental issue. Therefore, the conversion of steel slag in the form of a sand particle has not been attempted so far. And besides that, it is bit cost consuming process in comparison to conversion of blast furnace slag in the form of a granulated sand particle, or these sand particle can be further grounded to get it converted in the form of a ground granulated slag cement. Just a minute, yeah. So this particular slide depicts you the entire process, like how it can be done. The molten slag poured into the slag pit, and in the slag pit, this slag is air cooled, and there is a significant scientific methodology is involved in order to air cool the slag, so that the different intrinsic properties required for utilization of this material as a road aggregate can be developed. So CSIR CRI has recently developed the steel slag valorization technology, which has been given to different steel industries like ArcelorMittal Nippon Steel, JSW Steel, Tata Steel, and Rashtriya Nigam Limited, Ispat Nigam Limited, in order to convert the steel slag as a road making aggregate. So once this slag is air cooled, then it is transported into this dumper from the slag pit to the slag processing facility, and at the slag processing facility it is subjected on crushing and magnetic separation in order to remove the metallic iron content out of it, and subsequently the slag aggregate can be prepared using it. Now in terms of the application, if you will see, so my slide is changing. Am I audible to you? Hello.
Yes, sir.
Hello, sir.
Be continuous.
Okay. So right now on I am on types of iron and steel slag and potential uses. So these are the different types of slag which is generated out of the different type of furnace. Like one is the blast furnace. So the slag which is originated from the blast furnace can be used as a air cooled blast furnace slag. And as discussed, it can be granulated in the form of a granulated blast furnace slag, which can be utilized as a replacement of sand. And if it is further grounded, then it will become ground granulated blast furnace slag, which is having the highly cementitious and hydraulic properties. Therefore, it can be used in the manufacturing of Portland slag cement, as well as this material can be directly utilized as a replacement of OPC cement in pavement quality concrete. Now the second stage, the steel slag, which is primarily of two type: basic oxygen furnace steel slag, and another one is the electric arc furnace steel slag. So this basic oxygen furnace steel slag once again can be air cooled and granulated. So through the granulation process, we can develop the cementitious characteristic inside the granulated steel slag. Besides that, the reshaping of this particular size of particle in the spherical form for its utilization as a sandy material is not economical, since it is primarily a very high density material. So therefore, the majority of steel slag across India is air cooled, and its application as a substitute of natural aggregate in road construction has been explored. The third one is the electric arc furnace steel slag. So once again, it can be converted as a air cooled steel slag and the granulated steel slag. The air cooled steel slag goes into road application, while the granulated steel slag uh, can be utilized as a substitute of sandy particle. But once again, the conversion of EAF steel slag in the form of a sand particle is a very typical and cumbersome process. Besides that, it's a costly affair, so therefore no steel industry normally convert the steel slag in the form of a sandy particle. Now, as far as its application is concerned, like the blast furnace slag, being a coarse aggregate, like its generation is very less, since the majority of blast furnace slag is nowadays normally granulated in the form of a granulated blast furnace slag, and it is further grounded in the form of a GGBFS, and which has good export characteristic. Besides that, it is can be directly utilized as a replacement of cement. So majority of steel industries across India are converting the blast furnace slag in the form of a ground granulated blast furnace slag as a replacement of cement. The third one is the BOF slag. So BOF slag goes into road construction application as we discussed, like, but it require different sort of treatments. So in my subsequent slide I will share with you the challenges faced by the BOF slag, posed by the BOF slag, and what sort of treatments are required for it, and it can be utilized for the coarse aggregate application. And third one is the air cooled steel slag. So this air cooled EAF steel slag once again can become a good material for road construction activity. So now in this particular slide, you can see the ground granulated blast furnace slag GGBFS. So this is the heap of a granulated blast furnace slag in the form of a sand particle inside the steel plant. So it more or less looks like a sand heap, but this material, when it is further grounded, it get converted into GGBFS form. So it has milky white appearance, as you can see in this particular photograph. And on the right hand side you can see this is the ordinary Portland cement, and this is the GGBFS. So GGBFS has milky white appearance, while the OPC has the slaty color characteristic, and this GGBFS can be directly mixed into the PQC as a replacement of OPC. So what is the process followed into it? Like, the molten slag is removed from the blast furnace, and then it is put into the granulator, where it is subjected on rapid quenching of water. So with the help of this rapid quenching of water, this blast furnace slag get converted in the form of a sandy particle, and this process is called granulation. With the help, due to this particular process, the glassy content get developed inside the uh, granulated blast furnace slag, and this glassy content is normally between 85 to 90% as per the IS standard, for its utilization as a replacement of cement into pavement quality concrete. So if the glass content is less than 85%, then this sort of material will not have the requisite hydraulic and cementitious properties, and therefore all cement manufacturing companies reject the GBFS which has the glass content less than 85%. Now this granulated slag subjected on grinding in a mill, in a dedicated mill, and through this grinding process it is get converted into the ground granulated blast furnace slag, which has finest modulus as equivalent to cement, and it has very good hydraulic and cementitious properties. With the help of that, we can utilize it as a cementitious binder. So in terms of the chemical composition, like the GGBFS contain 38 to 50% calcium oxide, while the OPC contains 60 to 67% calcium oxide. The silica content in the GGBFS is normally 27 to 39%, while the silica content in the OPC is between 17 to 25%. Magnesium oxide is normally less than 10, while in OPC it is between 4 to 10%. Aluminium is between 8 to 20% in case of ground granulated blast furnace slag, while in OPC it is between 3 to 8%. So in terms of the major chemical composition in the OPC, it is more or less similar to the OPC composition, and therefore it shows very good cementitious properties, and it can be used as a replacement of cement. So what is the benefit of using GGBFS in cement concrete mix? Like, it offer high strength, it reduce the permeability, since it is a very fine powder, so it reduce it, basically pour all the permeable whites inside the concrete mix and reduce the permeability of the concrete mix significantly. High resistance to chloride penetration, since the Portland slag cement is high resistant, shows very good resistance to chloride and sulfate attack. Cement, or you can directly use GGBFS along with the OPC in order to construct a durable concrete structure in marine environment. Besides that, this sort of cement shows high resistance to alkali silica reaction. This is one of the major benefit of using PSC cement. It has lower risk of cracking, improved workability due to slower setting, better finish, whiter than the regular RMC. So if you will see in terms of color, like the GGBFS is basically milky white in color, while the conventional OPC is slaty in color. So in comparison to the conventional cement concrete mix, the concrete made with GGBFS will be comparatively white, and therefore it give you better finish and appearance. It eliminate leaching possibility. So since this is primarily a alkaline material, so the combination of GGBFS and cement reduces the possibility of leaching by virtue. Is there any question on? I could not hear you properly. Is there any question on the panel? Am I audible to you?
Yes, sir.
I think somebody asking some question, or I should go move ahead.
Please move ahead, sir.
So it offer improved workability, and besides that, the chances of shrinkage get minimized since this GGBFS contain high silica content in comparison to the conventional OPC. So the silica alkali reaction reduces the chances of shrinkage. It is a green product since by utilizing the GGBFS, we are facilitating the waste utilization in a productive manner. Therefore it offer a carbon credit, and since there is no clinker manufacturing process involved as happened in the construction of conventional OPC or PPC cement, therefore in comparison to that, this sort of material has low CO2 emission. It reduces the corrosion potentials, and therefore the steel bars or reinforcement placed inside the structure will have the longer durability in comparison to the conventional OPC and PSC cement. So according to IRC 15 2011 standard specification and code of practice for concrete road, Portland slag cement containing not more than 50% of GGBFS by weight can be used for the preparation of pavement quality concrete. So the major composition in Portland slag cement is the GGBFS, but its upper limit is restricted to 50%. So any PSC which you intend to utilize should not have the GGBFS content, should be more than 50%. So JSW Cement, Tata Steel is producing this Portland slag cement, and recently Ultratech is also starting manufacturing it. So particularly in the eastern part as well as in Maharashtra, the availability of Portland, Karnataka, the availability of Portland cement is very good, and it can be utilized as a substitute of OPC and PPC for pavement quality concrete work. The maximum quantity of PSC is once again limited to 500 kg per cubic meter, while the minimum quantity is prescribed as a 360 kg per cubic meter for the preparation of pavement quality concrete. IS 456 state that the Portland slag cement with slag content more than 50% exhibit better sulfate resisting properties. MORTH specification also stipulate the use of Portland slag cement conforming to IS 455 with slag content more than 50% instead of sulfate resisting cement. So in case of marine environment or the concrete structure is going to be remain submerged, it is better to use PSC cement in comparison to OPC and PPC cement. So here in terms of the how you will design with the different GGBFS content while you are want to cast a cube. So you first of all you have to cast a concrete cube with 0% GGBFS, means with conventional OPC or PSC cement. Then you can replace that OPC and PPC cement by 25%, 55% and 75%, and check how the strength is changing, and depending upon that you can fix up the quantity of GGBFS which can be utilized as a substitute of conventional OPC cement or PPC cement inside the concrete mix. So in comparison to the conventional concrete cube, these cubes will be milky white in color as you can see in this particular photograph. So therefore it has good appearance in comparison to the conventional cement based material. Now, as we were discussing, like the slag cooling process has significant impact on its properties, and therefore this is one of the scientifically designed process and method in order to utilize the slag as a road construction aggregate. Now, in case of the aggregate which is obtained from igneous rock group, Larnite is one of the important mineral which is found in abundance, and therefore this particular um, aggregate like the granite, basalt, like that, shows good mohr hardness. And when we want to convert this slag in the form of a road aggregate, then this sort of mineral should be maximized, and therefore we developed a entire slag cooling process. With the help of that, the Larnite mineralogical phase can be achieved inside the slag aggregate. So this slag cooling process also affect the surface appearance of the slag aggregate, as well as its surface structure can be controlled out of it. So fast cooling results, like if we will immediately cool the slag by pouring the water or spraying the jet of water on top of it, then it may result an abrasive surface due to presence of smaller grains at the surface. Besides that, this process also called vesicular structure in the slag, which absorb binder like bitumen binder and cement when we utilize it as a substitute of cement or bitumen inside the asphalt concrete or in cement concrete. So therefore this vesicular structure should not be there, and it should be as good as the aggregate produced through the process should be as good as the conventional natural aggregate in terms of surface appearance. The irregular and abrasive surface aggregate exhibits poor workability and difficult to compact while using different pavement layer. So if there is an irregular surface structure, we will face the difficulty in order to achieve the desired degree of compaction inside the different pavement layer. Now, where this kind of material can be utilized? So it can be utilized into different layers of asphalt pavement as well as cement concrete pavement. It can go into surface course, binder course, base course, sub base course, embankment, and subgrade. So this is the study like which has been conducted by CRI, and all of you might have heard or maybe aware about that. Like we have constructed a 6-lane 1 kilometer long steel slag road at Hajira Surat by replacing by substituting 100% natural aggregate using processed steel slag aggregate. So I will show you the photographs as well as video of that particular road which has been built using it. Now, in case of rigid pavement, like it can go into pavement quality concrete, DLC, granular subbase, like that. And we are utilizing this electric arc furnace steel slag aggregate on Mumbai Goa Expressway on NS 63 near Dolvi, and constructing this pavement rigid concrete pavement using steel slag aggregate as a 100% substitute of natural aggregate. In terms of the chemical composition, like how these steel slag aggregate differs from the natural aggregate, like the good quality natural aggregate obtained from igneous rock group like basalt and granite normally contain 5 to 10% calcium, while it is full of silica. The silica content between 45 to 50%, and in case of steel slag, it will be divide of silica, like it will be between 10 to 20%. So therefore, the steel slag aggregate are primarily calcareous in nature, while the basaltic aggregate or the granite are basically siliceous in nature. So in terms of the chemical composition, charge on the aggregate, like the steel slag aggregate, differ considerably than the good quality natural aggregate, while the iron content in the ferric oxide form FeO2 or FeO3 form between 10 to 30%. It can go up to 30% in some of the steel slag aggregates, while the in case of basaltic aggregate is it is between 5 to 10%. So the manganese content is between the 2 to 6%, while the manganese content in the natural aggregate is negligible, or some of the time it is not found inside that. Now, the one of the important characteristic is the presence of free lime, and this quantity of lime may pose volumetric expansion in the steel slag aggregate, and the presence of free lime is significant, particularly in the steel slag obtained from basic oxygen furnace process. Since in this particular process only hot metal is utilized, and in the hot metal, in order to reduce the quantity of impurities and carbon, we have to put the good amount of fluxing agent, particularly a dolomite lime inside the furnace, and this dolomite lime goes along with the slag and remain entrapped inside the slag in a free form. So when this lime comes into the contact of moisture, it causes volumetric expansion, and this expansion can be between 5 to 12%. And if this sort of aggregate is not treated, then the premature failure can happen in the pavement structure. So therefore, we devise the slag treatment or weathering methodology in order to facilitate the utilization of BOF slag aggregate in road construction. Now, so that's all on the front of the chemical composition of the aggregate. So in terms of the specific gravity, the steel slag aggregate is around 30 to 40% higher, heavier than the natural aggregate. The good quality natural aggregate is between 2.78 to 2.83, while the steel slag aggregate is between 3.1 to 3.5. Up to that much variation can be seen in the specific gravity perspective, depending upon the quantity of metallic iron is going along. Metallic iron is going in the slag. So if there is a high metallic iron content entrapment is there, then the specific gravity of the slag will be higher, and which can be reduced by removing the entrapped metal through the magnetic separation process. Now, this is the glimpse of the road like which we have constructed at Hazira, Surat using 100% processed steel slag aggregate. It's a 1 kilometer long 6-lane road which connect NS6 to Hazira port. So around 1200 to 1500 commercial vehicle per day are moving on this road, and which is carrying 30 to 40 ton payload, and all the layers including from subgrade to bituminous layer, all the layers of the bituminous pavement are constructed using processed steel slag aggregate. There is no natural aggregate inside this road. Besides that, the road median, road shoulders and side drain too are built through the processed steel slag. So this is one of the major significant achievement, like up to partial extent, let us say 20-30% replacement of slag has been attempted under the CRRI supervision on different projects, and we delivered those projects way back in 2015-16. But in 2021 this project has been completed, and in this particular work we utilize 100% processed steel slag aggregate as a substitute of natural aggregate inside the road. For last 1 year we are monitoring its performance, and we found it as good as the national highway in terms of the riding quality and serviceability parameter, and we can have the equivalent performance and better performance than the conventional road. So this is the aerial view obtained through the drone on this steel slag road. So this is the quality of road which has been built. So these both it's a 6-lane road. So this road median, all these lanes and even the side shoulder and roadside drains are constructed using processed steel slag aggregate. So it was like this particular road is in quite dilapidated condition. It is situated on a marine soil. It is situated and adjacent to the Hazira port. It's a big commercial port where all the goods of Reliance, L&T, ArcelorMittal, ONGC are moving through this particular section for the port, and due to that this road has developed a big size potholes, and even the several layers completely worn off. Even the therefore we took this challenge and designed this entire road using slag aggregate, and now for 1.5 years and so this road is completely intact despite subjected on a very heavy commercial traffic. So we carried out the axle load survey on top of it, and we found that the axle load between on this particular road is between 26 to 32 ton, and it is quite heaviest traffic like which we have witnessed in any of the section. Despite that, this road so far has not developed any sort of pothole. There is no sign of distress into it, and it is perfectly intact. So, like in terms of the composition, we carried out the parametric study on this particular section. We built a conventional road using conventional aggregate, natural aggregate, and bitumen for around 300-meter length. The road is designed for 100 million standard axle repetition for 20-year design life. We determine the payment composition as per the recommendation given in IRC 37, and then constructed a second section using the thickness as prescribed in IRC 37 for conventional aggregate road, and we built one section of 250-meter long of this particular thickness length. So once again, the pavement thickness is around 625 mm in the conventional as well as in the steel slag road section, as suggested in IRC 37. And the third section which we built is with slag. So from subgrade to top layer, we put the slag inside the pavement layers, and we reduce the overall thickness of the pavement by 32%. So this thickness reduction is achieved in WMM and dense bituminous macadam layer. And with 32%, we constructed the section, and that section is around 1.2 kilometer long. The all three sections are completely instrumented, and we monitored the stress, strain, deflection underneath the load in these particular three sections, and we found that the fatigue and rutting strain get reduced considerably once the section is built through processed steel slag aggregate. Now here you can see the view of the structural evaluation which has been carried out through heavyweight deflectometer on the steel slag road section. One of the important finding out of this study is that in case of the conventional road, at 40-ton impulse load, the deflection is around 260 to 371 micron, and this deflection is reduced to 50 to 60% when we tested it on the steel slag road section. So type B is with the conventional thickness and type C is with the reduced thickness. So despite having 32% reduced thickness in the pavement, the steel slag road is showing significantly lower deflection under the impulse loading. So by virtue of that, we achieved the highest structural stiffness inside the road. In this particular graph, you can see the steel slag road, the comparative deflection ball from D1 to D9 sensor in an inner lane. So in an inner lane, like the highest deflection is around 1,000 micrometer, and then this deflection get reduced to 400, between 375 to 400 micrometer. So it is almost 60 to 70% reduction in surface deflection, which is primarily the cause of fatigue and rutting strain in the pavement. And by virtue of that, the design life of this particular road, which has been found through the back calculation method after heavyweight deflectometer evaluation, is between 60 to 80 years in comparison to 20 years as prescribed in IRC 37. So it's a sort of a high durable road which has been constructed using 100% processed steel slag aggregate in comparison to the natural aggregate. Now, what are the challenges associated with the steel slag utilization? Like as we discussed in the previous slide, the steel slag contain the free lime, which can cause volumetric expansion if the untreated slag is utilized for the preparation of bituminous mix, or it is utilized in the unbounded layer or in granular layer. So in order to reduce this free lime content less than 3 to 4%, we have to subject the steel slag on alternate weathering or aging treatment. So with the help of this alternate weathering and aging treatment, we can reduce this free lime content by less than 4%. And a reduction in free lime content will indirectly reduce the potential of volumetric expansion, and when the volumetric expansion is around less than 3%, then this sort of material can be utilized for the road application. If this treatment is not done, then this sort of failure in the bituminous mix can happen. This is a Marshall specimen which we casted in our lab with the untreated BOF steel slag sample, and when we put it into the water bath at 60 degrees centigrade temperature, then within an hour itself, like due to the presence of high free lime, this sort of cracks is developed, and the mix is get crumbled when we removed out of the water bath. So therefore, in order to make it a good bituminous mix using steel slag aggregate, it is imperative to subject the steel slag aggregate on different aging treatment, and this sort of provision or the necessary modification is carried out by different steel plants before supplying these material to the road construction industry for application purpose. In the second photograph, you can see that the pop out which has been developed into the asphalt mix in case the untreated steel slag aggregate is utilized for the construction work. It is due to the volumetric expansion happened in the slag aggregate. Now, the second one you can see is the major challenge. In terms of the major challenges is the tufa formation. So the slag aggregate, due to presence of high calcium oxide, can oozes the CaCO3 deposition, which is it's a kind of a calcium carbonate deposits which is deposited on the top of a steel slag layer, steel slag road layer. This sort of things can impede the water drainage characteristic. Therefore, before its application, it should be treated. The third challenge is the slag with vesicular structure. So if the slag cooling process is not properly customized or scientifically handled, then the slag generated after the cooling will be of this type, will be of this surface appearance, and by virtue of this vesicularity, this slag will have higher binder demand in terms of bitumen binder or cement. And since the binder will pour all these whites and then it will cover the surface, so the binder demand will get increased significantly. So this vesicular structure can be controlled by adopting the controlled slag cooling process, which can handle the vesicular structure of the slag. So these are the two important aspects. The fourth one is the high metallic content. So if the slag aggregate contain high metallic iron, then this metallic iron will have the corrosion with time, and the slag aggregate will have the this corrosive appearance after 1 or 2 year time. So before its utilization, the slag aggregate should be subjected on magnetic separation in order to remove the metallic iron and trapped metallic iron from the steel slag. So the CSIR CRRI has customized this particular process in order to bring down the metallic iron content less than 4%. Whatever the metallic iron is recovered from the slag is basically recycled in the steel plant to produce the steel. So this is one of the glimpse of the metallic iron removal process which you can see in this particular slide. Now the fifth one is the presence of heavy metal and the possibility of high pH leaching. So in this photograph, you can see that the high pH leachate comes out from the slag deposits in the form of a white precipitates. These precipitates can contaminate the nearby water bodies and can pose challenge to the local flora and fauna. Therefore, it is advisable to treat the slag aggregate before its application. Even the stable mineralogical phases can be developed by adopting the suitable steel slag cooling methodology which has been developed as per the type of steel slag by the CSIR CRI and implemented into different steel industries. So this high pH leachate or heavy metals can reach up to the water bodies and cause negative impact to the local human beings as well as the marine environment. So therefore, it requires treatment before its application. So this is a glimpse of the steel slag processing methodology. Like this is the unprocessed slag. This is the glimpse of a slag with vesicular structure. Now this is the converted steel slag which has been achieved through the CRI process. So in terms of appearance as well as surface appearance as well as in terms of physical and mechanical properties, these aggregates are as equivalent to the good quality natural aggregate, and even giving us a superior mechanical performance. And this is the benefit of this conversion process in the form of a costing aspect. Like the slag aggregate is between 20 to 40 size is available between 160 to 180 rupees per ton. This is the cost analysis of EAS slab aggregate which be carried out for Hajira Surat ArcelorMittal Nippon Steel plant for 10 to 20 size aggregate. It will be between 200 to 210. So normally the cost of the process slag aggregate is around 50% cheaper than the natural aggregate available in that region. So therefore this material is economical, at least in the in all, at least in the all nearby regions. Besides that, the per ton transportation cost is slightly higher, like in comparison to the conventional aggregate. Since it is bit heavier than the conventional one, the per ton transportation cost will be between 6.5 to 7 rupees, while it is for 4.5 to 5 rupees per kilometer for the natural aggregate. Now, what are the important finding, like process steel, EAF steel slag aggregate, like which we I have shown you in our previous slide, can be utilized as an 100% substitute of natural aggregate in all layers of bituminous pavement, including median and shoulder portion. So this particular study has proven that like entire road structure can be built through slag aggregate without using the natural aggregate inside it. Load carrying capacity of steel slag road is found better than the conventional bituminous road built through natural aggregate. Riding quality parameter of steel slag road, as I have shown you in the previous slide, is at par with the road built through natural aggregate, while steel slag road is exhibiting better skid resistance under wet conditions. So in case like by virtue of the rough surface texture, the steel slag road wearing course offer better skid resistance under the wet condition in comparison to the wearing course built through natural aggregate. Overall bituminous pavement thickness can be reduced by 30 to 40% by using the processed steel slag material in all pavement layer. This is one of the major scientific achievement which can basically enhance the utilization. So use of process steel slag aggregate, which is at the primary instance is cheaper than the natural aggregate, and the reduction in pavement thickness, we can construct a asphalt road at 30 to 40% cheaper than the road built through natural aggregate. So in terms of the economics, like this material will offer you a cost economically option to construct a steel slag road with at a 30 to 40% lower cost than the natural aggregate section. So now we will take 5 minutes break and then I will discuss the second part. Okay. So am I audible to all of you? Since I cannot see the face of anyone, so it is very difficult to connect.
Yes, sir, you are audible, sir.
So now we will continue the second part after 10 minutes and so 5 to 10 minutes break and then we will continue.
Okay.
Okay, sir.
Thank you. cost comparison. So it will be available on 11th September. So you can just note down the link and all, and you can watch it from your home. Is it visible to all the participants?
Yes, visible, sir.
Sir.
It will be telecasted on Facebook, YouTube, and Twitter, and parallelly from India Science OTT channel, Geo platform also. So you can get it downloaded from the YouTube and other media. So you can just keep the screenshot or just have a photograph of this particular link www.indiascience.in, and through that you can run that video on 11th September at 12 p.m. So
Sir, your presentation is finished?
yes, from my part, all the technical content is over. If
Okay.
you want to discuss anything, we can
Yeah.
discuss it further or call it a day.
Now the participants are requested